let's move on to our next topic, which is electric potential energy. So, electric potential energy describes the potential energy of a particle, or the potential work that it can do. So, if you have a look at the diagram of the basketball on the right, you can see the potential energy that it has, and that is gravitational potential energy. And that's probably how you would have learnt about potential energy to begin with in maybe year 10 or year 11. So, we can also have our electric potential energy, or EPE. So, our electric potential energy is the same magnitude as the work done from one point to another. Alright? And for gravitational potential energy, GPE, we take the ground to be the reference point for zero gravitational potential energy. So, the same concept applies for electric potential energy. Alright? The reference point to 0 delta U for a test charge in this case is infinitely away from the rod, and the electric potential energy is equivalent to the work done to bring the test charge from infinity to point P. Alright, so it's kind of how much effort you have to put in to get the charge between point A and point B. So, let's have a look at how we actually calculate our electric potential. So our electric potential is described as voltage V, and it's the amount of electric potential energy per unit charge when a positive test charge is brought in from infinity. So we have V is equal to delta U, which is the change in energy, over Q. Alright, so let's have a look at a quick example. Alright, let's have a look at a quick example. So, the work done by the electric force as the point charge Q0, 2 times 10 to the negative 6, moves from point A to B, is work equals 5 times 10 to the negative 5 joules. We need to find what is the difference in electric potential between these 2 points, and what is the potential difference between points A and B. So, for this question here, we need to remember that the voltage is equal to the change in electric potential divided by Q. Alright, so this would help us find part B. The first thing that we need to do, though, is we need to find the difference in electric potential energy between the 2 points. And this is delta U here. So the difference for part A is 5 times 10 to the negative 5 joules. Because remember, the difference between the 2 points is equal to the work done. So, now we can go ahead and pop this in our formula. So we're going to have 5 times 10 to the negative 5 divided by the charge, which is 2 times 10 to the negative 6 coulombs. So we're going to have 5 times 10 to the negative 5 divided by 2 times 10 to the negative 6, which gives us an answer of 25 volts. And that is our potential difference.